Next, we need to look at some quadratic equations. This is all stuff you've seen before. At least if you've been in Math 95, you've seen all of this. Quadratic equation is just an equation of this form. Every quadratic equation can be rearranged until it has that form. You've seen or should have seen 4 different ways to solve a quadratic equation. We're going to briefly go through each of those 4 ways. First way, and the simplest way when it can be applied, is the square root property. Square root property says you can take the square root of both sides of an equation and it's still the same solution. So if you have x squared equals k, take the square root of both sides. The only condition that goes along with taking the square root is because square roots there's both a positive square root and a negative square root for every number. When you take the square root of both sides, you must put a plus and minus on the right-hand side. Not on the variable, on the other stuff. And I say other stuff because sometimes it will be a number, sometimes it'll be an expression. But you need to do the plus and the minus on that side in order to get both of those roots. A quadratic equation has 2 solutions. If you don't put the plus and minus, you won't get but one of them. So make certain you always include that. If your equation has this form, perfect square equals something on the other side, the variable has to be completely inside that perfect square. That's the requirement. If that is true, very simple solution. Works even if your perfect square is more complicated. Notice the right-hand side now is not a number. It doesn't matter. Take the square root of both sides. Now, when your perfect square is more complicated, you may have to do subsequent steps. I still have to solve for x here. So I have to add the 3 to both sides. But here are my 2 solutions, 3 plus the square root of s and 3 minus the square root of s, 2 solutions. You have to make certain you get both. Very simple, easy to apply solution process when the form of the equation allows you to use it. So that's the general form of the quadratic equation. Standard form, meaning descending order of exponents, equals 0. If it's not equal 0, you shouldn't be solving it. You should be, making it equal 0, then solve it. Second method to look at is completing the square. Actually, not going to go through the factoring process in this case. Completing the square. The square root property requires you have a perfect square. If you start out with a general quadratic equation, it is not going to be a perfect square usually. But we can change it until it becomes a perfect square trinomial, which means a perfect square trinomial is the square of a binomial. If we have the square of a binomial, we have that perfect square situation that we can apply the square root property to. So completing the square takes a general quadratic equation and forces it to become a square root property form, where we have a perfect square on this side and something else on this side. Then we take the square root of both sides and we have the solution. So here's where we're starting from. The method says if this coefficient is not equal to 1, divide the equation by whatever that is. We need that to be a plus 1. So divide everything by a. Then we're going to move the constant term over to this side. so that we just have the x squared term and the x term on the left side. And that's when it's like that, then we're going to take half of whatever this coefficient is and square it. That square we're going to add here and we're going to add here. Add the same thing to both sides. That method of taking half of this and squaring it is what forces this left side to become that perfect square. And if you look at what happens when you square a binomial, that's where it comes from. The left-hand side then, because we added the proper amount to that side, is a perfect square. It will factor into a binomial squared. And so we have a perfect square on the left side. We have some other stuff on the right side. We take the square root of both sides using plus and minus on the right-hand side. Then we finish the solution, solving for x equals. That's the completing the square method. So here's an example. We have a quadratic equation. First step would be to put it in standard form. It's already in standard form, so we don't have to rearrange anything. Next step would be to make certain that this coefficient in front of x squared is plus 1. It's already plus 1, so we don't need to do anything for that. Next step is I need to move this constant term to this side. So if I do that, I'm going to have that. Add 20 to both sides. X squared term and x term are the only thing over here. Now I'm going to look at this coefficient of the x. That's plus 10. I'm going to take plus 10 and divide it by 2. Then I'm going to take that and square it. So take half of that number and square it. That's 25, so add 25 to both sides. Still balanced, still true, because I added the same thing to both sides. This now is a perfect square. If I factored that, what I would get would be x plus 5 squared. You can verify that for yourself, that is what happens when you factor that. If you FOIL x plus 5 times x plus 5, you'll get x squared plus 10x plus 25. So what I have on the left side is a perfect square. My variable is completely inside the perfect square. Therefore, I have the situation to which I can apply the square root property. And it is useful to do so. I can always apply it. It's just that in many cases it's not helpful. In this case, it's helpful. When I have the situation where my variable is completely inside this perfect square. Take the square root of both sides, use plus and minus on the right side. Square root of the left side is just what's inside the parentheses. Right side, I have plus and minus. If I simplify my radical, 45 is 9 times 5, right? 9's a perfect square, so I can take 3 out. Now my right-hand side is simplified. Solve for x. Subtract 5 from both sides. I have to watch my signs. I'm subtracting 5 from both sides. Here are my two solutions to this equation. Yes? Divide by 2. Everything, whole equation. You can't divide just part of the equation. You have to divide the whole equation. Yeah, divide everything by whatever that number is, including whatever sign it has. If it's a minus 2, divide everything by minus 2. And then you would look like this. Well, first move this number over, then get half of that, and add, square it and add it, then take the square root, then solve. Right, and order of operations says we have to multiply that before we can add that number, right? It's still, if you follow order of operations, you'll be correct. Order of operations says we have to do this multiplication before we can do this. So I can't add those and then multiply. That violates order of operations. But yeah, you're correct also. It's a different term and the two terms are not alike. Completing the square. You probably looked at completing the square previously just for solving quadratic equations like we're doing here. We're going to use it for some other things. When we look at circles, when we look at parabolas, we're going to need to use completing the square to do that. So we're going to use this technique later where it doesn't specifically apply to quadratic equations. So you do need to know how to do this set of steps. Okay, so there's the process cleaned up a little bit. Any questions about completing the square? All right, that's second way. Actually, the first way you saw to solve a quadratic equation was by factoring. You put it in standard form, you factored the polynomial, you set each factor equal to 0, and solved those, and they gave you the solutions. Second way is the square root property we looked at a minute ago. Third way is the completing the square, and the fourth way is the quadratic formula. Make certain you have this memorized. Will not be provided. Make certain that you have it memorized correctly also. This fraction bar extends the full width of the right-hand side. Fraction bar goes underneath the minus b, not just the radical. Make certain you keep that straight. Make sure you get all your signs correct. If you mess up a sign, you're going to get the wrong answer. Okay. When you're going to use the quadratic formula, and actually I don't think I do it in this class, but quadratic formula, if you start with the general form of the quadratic equation, if you start with that and apply completing the square to it, you'll get this. And I'm guessing, but my theory is that the mathematicians discovered completing the square first and kept doing it to solve quadratic equations, and they saw they were doing the same thing repeatedly. They said, well, why don't we just see if we can put it in a form where all I have to do is plug the numbers in. And they said, okay, well, if we do it generally, we get this. And then what we always do is, all we need to do is plug in A, B, and C, and we can get the answer without going through all the rest of that stuff. And that's indeed true. That's where and so the quadratic formula can actually be derived from this using completing the square. Okay, if you're going to use the quadratic formula, first of all, you have to remember it. Next, you need to have the equation in standard form. It's possible to use the quadratic formula without putting it in standard form, but you run the risk of getting incorrect values and incorrect signs to plug in there. My recommendation, strong recommendation, anytime you're working solving a quadratic equation, no matter how you're going to solve it, is put it in standard form. One exception would be if it's already in the square root property formula. form. If it's already a perfect square, just go ahead and take the square root. Otherwise, put it in standard form. That's whether you're factoring, completing the square, or quadratic formula. Put it in standard form to start with. Once it's in standard form, then identify what A, B, and C are. A, B, and C to go in here. A, B, and C all have signs. They're either positive or they're negative. Make certain you get the proper sign. If you don't, your answer is going to be wrong. So identify what A, B, and C are. I suggest, and I usually will do this. I don't do it every time, but I usually will. I'll write my equation down, and underneath I'll write A equals this, B equals this, C equals that. So I make certain I have the number and sign right there in front of me for when I start substituting in here. Then I will also write down that formula. And then I have the A, B, and C right here and the formula right here, and I can substitute in and make fewer mistakes with signs and values. I think that's a good way to proceed. Substitute the values in, do the arithmetic, and get the answers. Because of the plus and minus here, you should wind up with two answers. Now, there are occasions where the sum under here sums up to, or this difference is 0. In that case, you get a single number out. That's going to be, we'll refer to that later, it's called a root of multiplicity 2. It's where you have the same answer twice. So officially, that still has two solutions. It's just the same number twice. So here's an example. What's the first thing I want to do? Put it in standard form. Which means I need to do what to this one? Need to move the 3 over, don't I? I'm assuming people can follow what I'm doing without me putting every step in. All I did was subtract the 3 from both sides. Okay? What else do I need to do? Do I need to make certain this is plus 1? Quadratic formula does not require that. This can be whatever number it turns out to be. So in that sense, it's easier than completing the square. It does not require any modifications once it's in standard form. All right, now what? Okay, I'm going to actually write them down rather than just labeling them. Oops, I have to write what I mean, not what I'm... Okay, and then I do what? And the formula is what? And if you don't have that down, you need to get it down because you're going to have to do just that very thing with no assistance. You're going to have this formula. Because now I can plug my numbers in, can't I? Okay, minus b. Well, b is 6. I'm going to get minus 6. And then I have plus or minus the square root of, and then I have b squared. Well, b is 6 minus 4a. A is 1. C is minus 3. And that's all over 2 times A. A is 1. And there are my numbers. Notice I was using parentheses around each of the things I substituted in. There are a couple places it's not going to matter, but there are cases where it will. Because my b is a positive number here, I didn't really need the parentheses here, but if b had been a negative, that's a minus a minus. Yes? I'm sorry? sorry? Yeah, you need to come back after class. Okay. When this number's positive, it doesn't really matter, but when it's negative, it's important that you get both negative signs in there. And so if you always use parentheses where you're substituting a variable in, then it just helps you always have a place to make sure you get the right sign. Do the arithmetic now. And you're not finished till you reduce to lowest terms. Did I get it right? Or did I make a mistake somewhere? And 3. If you do it over and over and over again, it sticks, and I've been doing it for years. So I used to know, I recommend that you know all the squares up to 10 squared and all the cubes up to 5. When I was in school, because I didn't have calculators, when I was in graduate school, just about to graduate with my PhD, the guy I shared an office with as a graduation present received a Hewlett-Packard calculator. Brand new, state-of-the-art, did add, subtract, multiply, divide, and take square roots. It wasn't real big, but it cost $400. That's why it was a graduation present, because it was so expensive. So we did everything with slide rules and pencil. You probably don't even know what a slide rule is. But I learned a lot of these, and because I had to keep doing them repeatedly, I actually memorized the squares up to quite a ways, up to 20 or so, just because I was using them. But because we don't do that anymore, you don't need to have that. But it is extremely helpful to remember the squares up to 10 and the cubes up to 5. If you remember more than that, that's great, but those are definitely helpful. Okay, quadratic formula. It will most likely be your method of choice unless you can see an easier method. If you look at a problem and don't immediately see an easy way to do it, then go to the quadratic formula. If you look at it and say, oh, square root property works, all I have to do is take square root, that's going to be easier than this. This works, but this will take longer, be more steps than if you use square root property. But remember, square root property only works under certain cases. I doubt you'll ever deliberately do completing the square unless you need it for something else. And we will need it in a couple of places to do other things. Factoring, sometimes you can look at a polynomial and say, oh, that factors into this and this. If you do, that's going to be quicker than doing this. But if you don't look at it and immediately see that factoring, I wouldn't waste time trying to find factors. I would just go ahead and do the quadratic formula. Because you could spend time trying to factor a polynomial which is prime. Quadratic formula will work no matter whether it's prime or not. You must know how to do the quadratic formula. It's an absolute necessity. So any questions about how to apply the quadratic formula? The setup, the solution, any of that? Okay, good. Okay, so if you have an equation like this, I actually tell you which way I want you to solve it, But you should be able to look at this equation and tell that the best way to solve that would be the square root property. What are your clues that you would know to use the square root property to solve this? Okay, this is a perfect square. What else? There's one other thing. I'm sorry? Well, yeah, that's a perfect square. That's what she said. This is a perfect square. That's one of them. There's another thing besides it just being a perfect square. Your variable is completely inside this perfect square. I don't have a variable outside that's perfect square. Those are the two things. It needs to be a perfect square, and it needs to have the variable completely inside that perfect square. If it meets those two conditions, square root property is far and away the easiest way to solve it. And this meets those two requirements. So what would the solution be? What's x equal? Like that? Yeah. All you have to do, take the square root of both sides. 2x plus 5 on this side, plus or minus square root of 7 over here. Subtract 5, divide by 2. So very simple process if it meets those two requirements. All right, let's do this one by factoring. So think back. I know it's been a while since you factored. Think back, how do you factor this? We're going to be doing factoring in many cases, so you will need to continue to be able to do factoring. And I'm not, you notice this is not just saying factor this polynomial, it's saying solve this equation using factoring. So you have to do the whole step, all of the steps. What do we get for solutions here? Everybody get x equals -4 and x equals +2. Remember, when you're using the factoring, factor the polynomial, then take each factor that has a variable and set it equal to 0 and solve those linear equations. That includes any common factors that you factor out. If that common factor has a variable, you must set it equal to 0 and solve. That's important, otherwise you lose one of the solutions to the equation. But if it does not include a variable, then you don't set it equal to 0. Only the ones that have variables. Okay, then yeah, I want you to practice this. See if you can do the completing the square procedure on this one. Remember, completing the square, you want it in standard form. You want the coefficient equal to +1. Then you want to move the constant term. You want to take half of that coefficient of x, square it and add it to both sides. Then you take the square root of both sides and finish the solution. 7 times 7, or minus 7 times minus 7 gives 49. And 2 times 2 gives 4. I did. I had minus 7 here. Half of that's minus 7 over 2. So divide that number by 2 and then square that. If you take minus 7 divided by 2, you get minus 3.5. Or you get 7 halves. Well, I need to combine this and this. So I have to write this as a fraction, right? Common denominator is 4, so it's 48 over, or negative 48 over 4. This is positive 49 over 4. So it's negative 48 plus 49 over 4 gives 1 over 4. Take the square root of both sides. Put a plus and minus. Now I jammed several things in there. It's got kind of tight, but yours should look something like this. You're talking about here or over here? Here? Well, this minus 48 plus 49 is plus 1 over 4. And if you're not sure, take it offline after class and work through it yourself. Put all the steps in. If you're a little confused, I'm combining some steps here. Do one step per line. That's the way to see clearly what is supposed to happen. Just do one step on each line. I didn't have a lot of space here, and at this point, some of the things you should be able to follow without having to have each step individually separated. But if you're not certain, start from here and go through it step by step. One step per line. From here, you should at some point get to here. Then from there, you should at some point get to here and here, and at some point here and here. So I've left out a few steps, combined a few steps. In general, that hits the high points, though. You need at least that many steps, I believe. Might have been able to get by with one fewer step over here. So the answer, x equals 4, x equals 3, this actually factors. And you get to 4 and 3 much easier. Okay, I'm not going to have you do the quadratic formula right now.